Okay, my screen PowerPoint presentation is visible to all?
Yes, sir.
Yes.
Okay. Okay, I am presenting now. Okay, so in our last lecture we talked about the various terms related to digital data communication, that is analog to digital conversion, digital to analog conversion, analog to analog conversion, digital to digital conversion, sampling, bandwidth, etc. So now, for example, in this slide we can see a hilltop fire is generally a fire alarm used in the hilly areas or hill stations, where what is a carrier? The carrier is a light, and what type of signal it is? It is generally blink on or off to represent that there is some fire at the hilltop in some hill station. In case of telegraph, what is the carrier which transmits the signal? That is electric current. And what type of signal is carried? Signal is on or off, that is in the form of some code, and that code is called as Morse code. Cable TV carrier is the infrared in optical fibers. You know the cable connection are through the cable wires, which are coated in 3-4 different layers. Inner layer is a conductor, then we have a plastic, and then outer jacket, which is also a conductor, and further one more plastic is there. So the carrier is the infrared in optical fibers. What type of signal is carried? That is ultra fast on or off pulses. The pulses may be rectangular or triangular pulses. Mobile phones have the carrier as the microwaves, and the signal carried is ultra fast on or off pulses, and these pulses are again the rectangular or square wave pulses. AM radio, the carrier is the radio waves, the radio frequencies, which lies between some 20 Hertz to 20,000 Hertz, and the signal is carried is in the form of changing amplitude, and that is called as amplitude modulation of the carrier wave. FM radio, the carrier is the radio wave again, the frequency ranges from some Hertz to some 1000 Hertz, and the signal is carried in the form of changing frequency, which is called as the frequency modulation. Now, let us discuss about what are the classification of electronic communication system. We can classify the electronic communication system in 3 different ways. The direction of communication, whether it is a single direction communication or a bidirectional communication. Then the type of signal, whether it is an analog signal or a digital signal. Then the third one is the baseband transmission, that is signal is transferred as it is or it is modulated in terms of the amplitude, in terms of the frequency, phase, position, or so. So electronic communication is divided into 3 separate categories: unidirectional, bidirectional communication, which is further divided into 3 categories: the simplex system, half duplex, and full duplex system. Nature of information signal, the communication system is divided into 2 categories: analog electronic communication systems, digital electronic communication systems. Third is technique of transmission, that how we transmit the information, whether the information is sent as it is or it is modulated on some carrier wave. So that it is further divided into 2 categories: the baseband transmission and the communication using modulation. So one by one we will discuss them. Classification based on the direction of communication. It is simplex, half duplex, and full duplex. In simplex, we have a unidirectional communication, whereas in half duplex and full duplex, we have bidirectional communication. Now, where is the difference? The difference is in simplex system, we have electronic communication system just like the radio transmitter or the TV transmitter. So in radio transmission, FM transmission or TV transmission, we cannot communicate both ways. Only we will receive the signal, and whatever is presented or is shown to us, we cannot alter it, we cannot change it, we cannot modify it, we cannot give the feedback. So only the communication is only in the one direction. that is from the transmitting station. There is no communication from the receiving end. Half duplex system. Half duplex system are the bidirectional communication system, which are called as the duplex systems. In half duplex systems, we can communicate both ways, but what is the difference is that we can communicate both ways, but not simultaneously. Here, word simultaneously is important because the communication will be done in both directions, but one at a time. The example is walkie-talkie set or so. So only one user will speak once, another will listen. The second user will speak after the first user, and then the first user will listen and second user will speak. So communication is both ways, but it is limited that it is not simultaneous communication both ways at the same time. Now the third one is the full duplex system, in which we have the bidirectional communication, and the communication can take place between both transmitter and the receiver at the same time. So the simultaneous word is important here in the full duplex system. It means the both ways direction communication is possible, and both users can speak, can listen at the same time. So hence the name full duplex system for the telephone system, mobile system also, or this Google Meet or Zoom class are the bidirectional systems, full duplex systems. The teacher can explain the subject and student can ask the questions at the same time. So it is a bidirectional system. Comparison between the half duplex and the full duplex system. In half duplex, we have communication in two ways, but one at a time. Full duplex, communication in two ways, but simultaneously both the users can speak. Examples of half duplex and full duplex are the walkie-talkie and the telephone. Comparison between the simplex and duplex system. The half duplex communication in one way, full duplex communication in two way, and half duplex the radio and TV broadcast, full duplex telephone. Sorry, this half duplex should not be there, it should be simplex in the heading in the third column. It should be simplex versus duplex. Classification based on the nature of information signal. We know we can have two types of signals, analog and digital signal, and due to two types of signals, we can have four different types of communication systems: analog signal to analog signal communication, digital to digital communication system, analog to digital communication, and digital to analog communication system. So let us first discuss the analog communications. In analog communication, we know the signal is in analog form. The signal is continuous. It varies continuously in amplitude, phase, frequency, or so. So we can divide an electronic communication system in terms of analog and digital, and analog communication system can further divided into two categories. That is continuous wave system. We will have a carrier wave, and the information or modulating signal will be superimposed upon the carrier wave, and accordingly we can get that signal, and correspondingly they will be called as the amplitude modulation, frequency modulation, phase modulation. In case of pulse modulation, we will have the carrier wave as in the form of a pulse, and in pulse modulation we can divide it into three categories: pulse amplitude modulation, pulse width modulation, and pulse position modulation, that is PAM, PWM, PPM. Digital communication system can be divided into three separate categories: pulse code modulation, PCM, delta modulation, analog to digital modulation. So here, examples of analog modulation are the amplitude modulation, frequency modulation, phase modulation, pulse amplitude modulation, pulse width modulation, pulse position modulation. So how to do this or how to achieve? Can you see the slides? Okay, thank you. So now we will learn how to achieve this modulation in amplitude or frequency or phase. With the help of coming few figures, we will learn. For example, in this figure, you can clearly see the first signal. The first signal is similar to some sine wave, which is, let us call it as a baseband signal or a modulating signal. Means this is our original signal, the first signal which we want to send. And EM represents its maximum amplitude. X-axis represents the variation of this signal in time. So how this signal is continuous. So it is an analog signal, and this signal carries some information, say some speech, some music, some sound, some voice, etc. So all these things are some information which is carried in the signal, and the signal is represented by continuous waveform similar to some, say, sine wave or so. So we call this signal as the baseband signal or the modulating signal. Now how to vary this signal or how to transfer this signal from one station to the another station, or we can say from the transmitting station to the receiving station. For this we adopt an old methodology that is called as superimposition of a signal on a carrier wave. So what is a carrier wave? A carrier wave is a wave which has continuous distribution of the frequency and same amplitude. So when this baseband signal is superimposed upon a carrier signal, and the maximum amplitude of the carrier signal you can see in the diagram is represented by EC. So whenever this baseband or modulating signal is superimposed on carrier signal, now this baseband or modulating signal, what it will do? It will try to change the amplitude, frequency or phase of the carrier signal. Since we are now discussing the amplitude modulation, so in this case, the baseband signal, the first figure, it will be superimposed upon the carrier signal, that is second figure, and this will try to change the amplitude of the carrier wave. Now in the third figure, you can see the amplitude of the modulated signal is EC plus EM. EC is the amplitude of the carrier wave. EM is the amplitude of the modulating wave. When these two are superimposed upon one another, then the amplitude will vary between EC plus EM and EC minus EM. And the shape of the envelope in the third figure you can clearly see is somewhat similar to the modulating signal, that is a sine wave type signal. So here the few things are clear. We will have some information. That information is transferred into some signal. That signal is called as modulating signal. And that modulating signal has to be superimposed upon carrier wave. Carrier wave are nothing but the high frequency constant amplitude waves whose purpose is just to carry the information, that is modulating signal. And how they carry the information in the form of some superimposition of a modulating signal and carrier wave. This superimposition, what it will do, it will redistribute the energy in the carrier signal, and redistribution of energy in the carrier signal will result into the variation of amplitude, frequency or phase of the modulated wave. And this modulated wave is shown as the third figure. Third figure is similar to the first figure in the shape of the envelope. So the modulating signal after superimposition changes the amplitude of the carrier wave, and amplitude varies from EC plus EM to EC minus EM. So this explains what do we mean by the amplitude modulation. This figure again shows the variation of amplitude. You can clearly see the regions of low amplitude and regions of the high amplitude. Next is the frequency modulation. Again, we can say that that we will have some baseband signal, we will have some information. That information is the modulating signal, and that is superimposed upon some carrier wave, and that carrier wave will now try to change the amplitude, frequency, or phase. If it changes the amplitude, then it is called as amplitude modulation. If it changes the frequency, then it is called as frequency modulation. So you can clearly see in the figure, the first figure represents the modulating signal. When this modulating signal is superimposed on high frequency carrier wave with constant amplitude, then this baseband signal will now try to redistribute the energy, and it will try to change the frequency of the carrier wave. You can see the reason in second figure. Let me highlight the reason. You can clearly see the reason in red in first part have very low frequency, whereas in the second part has higher frequency. Similarly, here also the low frequency region and the higher frequency region. So here, as the name suggests, frequency modulation, the modulating signal will be superimposed upon high frequency carrier wave. The high frequency carrier wave will result into redistribution of the energy, and redistribution of energy will take place in the form of increased frequency range or decreased frequency range. So in turn, what we can say is that whenever baseband signal is superimposed upon carrier wave, there are only three possible ways of changing the carrier wave, and these three possible ways are the change in amplitude, which we have done on the previous slide, and change in the frequency, which we are studying in the present slide, and change in the phase. So you can see very clearly in first position the frequency is low, in second position the frequency is high, again in the third position the frequency is low, and again in the fourth position the frequency is high. So the baseband signal has transferred or changed the frequency spectrum of the carrier wave, and hence the name called as frequency modulation. Similarly, the third technique, that is called as the phase modulation. Again, what we will have? We will have a carrier wave of this shape, let us say sine wave, and we will have a this will act as a baseband signal or the modulating signal, and this modulating signal is superimposed upon the carrier. Carrier is nothing but the high frequency wave, and whenever this modulating signal is superimposed upon the carrier signal, it will try to change the one of the three parameters of the carrier wave. That is, it will try to change amplitude, then it will be called as amplitude modulation. If it tries to change the frequency, it will be called as the frequency modulation. If it tries to change the phase, then it will be called as the phase modulation. So now let us try to say, let us try to understand how this phase modulation is changing in case of superposition of modulating signal on the carrier wave. So here we can say in the first phase, the carrier is stretching and there is a lag in phase, whereas in second position, there is phase leading the carrier wave. If you compare the reasons, then we can clearly see in these reasons, in first reason the carrier is stretching, and in the second reason the carrier is leading. So in reason 1 we say phase is lagging behind, in reason 2 the phase is leading the carrier or modulating signal. Similarly, we can also have the analog modulation in terms of pulse amplitude modulation and pulse width modulation. Again, what we require? We require a signal, let us say S is some signal. Then we require a high frequency carrier written as C. Whenever this signal is superimposed upon some carrier, then it will try to change the position, width, amplitude, etc. of the carrier. So on superposition, if amplitude is changed, then it will be called as the pulse amplitude modulation. If it changes the width, it will be called as width modulation. So you can now clearly see in the third figure, whenever this modulating signal is superimposed upon some carrier, then it will try to change the amplitude. You can compare the amplitude is continuously increasing, then decreasing in the negative direction, increasing, and so forth. So since it is changing the amplitude, it will be called as pulse amplitude signal. And if it changes the width of the signal, then it will be called as the pulse width modulation. So you can see here, the width is first increasing and then constant and then decreasing in this direction. So whenever we want to modulate a signal, there are 6 possible analog modulation techniques. We can alter the amplitude, frequency,
Excuse me, sir.
and correspondingly they will be called as amplitude modulation, phase modulation, frequency modulation. Then if
Excuse me, sir.
हाँ जी बोलिए
सर ये
हेलो
फेस बिट मॉड्यूलेशन में सर ये जो चेंज हो रही है बिट, सर जो फेस बिट मॉड्यूलेशन में बिट चेंज हो रही है वो कैसे चेंज हो रही है?
वो
कैसे चेंज हो रही है, मतलब कि जो ये बिट ले रखी है ये कैसे चेंज हो रही है?
हाँ okay, this width is nothing but simply a voltage signal. Hello.
Yes, sir.
Hello. Am I audible now?
Yes, sir. Yes, sir.
Okay. Now let me explain. Okay. So the question is how this width is changing. Okay. So what actually is happening? How the information is transferred? First, we have to understand this. The information is transferred in the form of the voltage signals or current signals. So whenever there is a change, what are the various parameters which represents a voltage signal? The parameters are the time, the angular frequency, the linear frequency, the amplitude of the voltage or so. So what is changing? There may be amplitude variation in the voltage, which will be called as the amplitude modulation. We will have some certain frequency of the electric signal, let us say 50 Hertz. So if that is changing, frequency is changing, that will be called as frequency modulation. If phase is nothing but a representation of the voltage signal in this space, and if that changes, it will be called as phase modulation. Now, each voltage, if that repetition is altered, that will be called as pulse width modulation. So the voltage level or signal levels are changed in modulation, and that's how width is changing. Hello?
Okay, sir.
Hello?
Yes, sir.
Okay. So I think it is enough for today. We will meet again tomorrow, and this link will be on for 1 or 2 more minutes. If you have not